Welcome to U3L7 distance formula. So there's a special relationship between the three sides of a right triangle. Specifically, the Pythagorean theorem states that the sum of the squares of the legs is equal to the hypotenuse squared. So first I want to talk about what the Pythagorean theorem says, because the distance formula is an application of the Pythagorean theorem. Okay, so here, first of all, I want to point out that I have a right triangle. I know that because of the right angle. And the two sides that meet at that right angle are the legs. And then the side across from the right angle is the hypotenuse. So basically, A and B are both legs of this right triangle. And then C, which is across from the right angle, is going to be our hypotenuse. And what is true about A, B, and C when A, B, and C are defined as A and B are legs and C is the hypotenuse is that A squared plus B squared is equal to C squared. And so knowing that, if you know two of those lengths, any two of those lengths, you can find the remaining third one. All right, so for example 1, it says find the missing side length in the right triangle below. So it's a right triangle. So first of all, let's label what A and B are and what C is. A and B are either of the two legs. It doesn't matter the order. So, and then C is the hypotenuse. I'll actually label C first. So across from our right angle is C. So X is C. So the unknown is C. And then A and B are the other two. I'll just put A is 6 and B is 8. Of course, they're kilometers. So our units for kilometers will be in the answer as well. All right, and let's go ahead and just use our Pythagorean theorem. So A squared plus B squared equals C squared. And we know A and B, so let's substitute those in. So A is 6, so 6 squared, plus B, which is 8. 8 squared is equal to X squared, putting the value that we're missing. And then 6 times 6 is 36, plus 8 times 8, which is 64, is equal to X squared. Be very, very careful that you do 6 times itself here and 8 times itself, not 6 times 2, right? This actually means the number times itself. All right, and then we're going to add those two values together, 36 plus 64, to get 100. And now here, if I want to know what the x value is, but I have x squared equals, I can do the inverse of squaring. So the inverse of squaring something is taking the square root of it. So here, if I take the square root of both sides, then I end up with x by itself. And then whatever the square root of 100 is what it's equal to. In this case, the square root of 100 is 10 because 10 times 10 is 100. So our answer here is 10. Now, keep in mind, there is another value that would actually work here, and that's negative 10, because if I did negative 10 times negative 10, I would get positive 100. But because we're working with the side length of a triangle, I can't have a negative value there. So we're only going to use the positive value here. So our final answer is going to be that x is equal to 10 kilometers here. 10 kilometers. Okay, let's look at the next one. Find the missing side length in the right triangle below. Leave your answer in simplest radical form. So taking a look here, again, let's look at the hypotenuse first. So across from the right angle, we have C, which is our hypotenuse. And then A and B are either of the other two. Again, it doesn't matter which one is which, as long as you have A and B as the legs. Now let's substitute everything in. So we have A squared plus B squared equals C squared. A is 9, so 9 squared, plus B, which is x squared, is equal to C squared, which is 11 squared. Now, simplifying this, we do have to square our 9 and our 11. Keep in mind, though, they're on opposite sides of the equal sign. So 9 times 9 is 81, plus x squared is equal to 11 times 11, which is 121. But in order to solve for x squared, we need to get this x squared value isolated. So that means we need to subtract this 81 on both sides. Okay, that's the only way we're going to be able to isolate that x squared value. So we're going to subtract 81 on both sides of our equation, leaving us with x squared is equal to 40. Okay. Now here we're going to do the same thing that we did earlier when we had to get solve for x, but we had x squared, right? Which is to take the square root of both sides. So we're going to take the square root of both sides. But this time, the square root of 40 is not a nice number. If you were to put that into the calculator and use your second button and then the x squared button to do a square root and type it in, you will get a decimal. You'll get that that's about equal to, and I can actually show you on my calculator. It's a different one than the one we use at school, but that's okay. So you'll see that if you use the square root, okay, hopefully you can see that, that you will get 6.324555532, and it keeps going. Okay, and again, I clicked second, and then I clicked the x squared. It's the same buttons on our calculator at school, but that is the approximation, the decimal approximation, about 6.3. Okay, so about 6.3, but it says here to leave our answer in the simplest radical form. So it wants us to leave it in the simplest form of a square root. So instead of writing that radical answer, or decimal answer, excuse me, we are going to simplify this radical. So 40 can be broken down into what, 4 times 10. Those are not prime, or not, yeah, they're not prime. So 4 is 2 times 2. Those are prime. 10 is 2 times 5, which also prime. So we can write the square root of 40 as square root of 2 times 2 times 2 times 5. And then we have a pair of 2's that has a square root. So that's outside the radical. But the 2 times 5 do not have square roots, so they stay in. 2 times 5 is 10. So the simplified answer, the simplest radical form answer is 2 square root 10. So our x value here is going to be 2 square root 10 and then feet. So same units as we had on the original problem. Perfect. Okay, so now we're going to move forward to figuring out how the distance formula is the application of the Pythagorean theorem. Okay? All right, so looking at example 3, it says find the distance between points A and B with coordinates A, 2, 3, and B, 14, 12. Sketch a right triangle on the grid that could be used to calculate the length of AB using the Pythagorean theorem. So basically the distance between points A and B is the same as the length of the segment that connects them, right? Those are the same by definition. And so because we have a grid here, we can just draw a triangle in. So we can basically do, kind of looks like slope almost, right? We can make a right triangle here. Oh, I made it too tall. Hold on. Okay, let's try that one more time. So I'm going to make a right triangle here. And then that's going to be the right angle up there at the top. Okay. So now what I can do is if I just figure out the lengths of those two sides, which are the legs of that now right triangle, then I can apply the Pythagorean theorem. Okay, so let's see. So going from A up, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's in 9 units. And then across from where we ended off at the right angle, right, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 units wide. Okay. So the two legs are 9 and 12. So then all we have to do is use the Pythagorean theorem. So the two legs are A and B. So we can call this one A and this one B. So we have 9 squared plus 12 squared is equal to, and then we can just, since it's AB, we can just call this length AB. You could call it X if you wanted to. I'm just going to use AB squared to use our notation there. And then we're just going to do the same thing we did earlier. So 9 times 9 is 81, plus 12 times 12 is 144, is equal to AB squared. Add your 81 and 144 together, and you're going to get 225. And then remember, in order to do the inverse of squaring, you just take the square root on both sides. The square root of 225 is going to be 15 here. It is a perfect square. So 15 times 15 is 225. So our length of AB is 15 units. Okay, so now the question it's asking here is, without the graph, how can we calculate the length of the length of the legs, excuse me, typo, from the right triangle in part A using the coordinates. So like if I didn't have a graph, right, let's just say I didn't, but I did know the coordinates, right? I knew the coordinate for A, I knew the coordinate for B. How could we calculate these lengths of 9 and 12, right? Okay, well what I see is this. So to get 9, we counted from A up. So basically we figured out the y distance, right? Which is the same as 12 minus 3. Okay, and that's 9. But then to find the distance across, we did the same thing, right? We just counted sideways, and that was the change in the x values. And so that was the same as 14 minus 2. That's 12. So all we have to really do is find the difference in the x values and the y values, okay? So without the graph, how can we? So we can find the difference in the x values and y values. Okay, so even without graph, we could have found those numbers by just subtracting, right? That's really what the difference is, by subtracting. Okay, so that leads us into the distance formula. So the distance formula is an application of the Pythagorean theorem in which the legs are found using the x and y coordinates, and then the hypotenuse is now the distance, right? So the hypotenuse of the triangle up here was the distance between A and B. So this hypotenuse was the distance between A and B. Okay, so for 2 points, x1, y1, and x2, y2, so for 2 generic points, the distance between those 2 points can be found using the following formula. So it's basically the same as the Pythagorean theorem. Okay, it's basically the same as the Pythagorean theorem. So let's write this out. So in order to find the distance, you're going to do what would have been a squared, which is now just subtracting the x's and squaring your answer, plus what would have been b squared is now subtracting your y values and squaring the answer. And instead of being equal to hypotenuse squared, it's now equal to the distance squared. So d squared, d for the distance. Okay, so the distance, if we call that d, then this is the formula that will find the distance between any 2 points. All right, so let's go ahead and apply that. So example 4, find the distance between the points G, 3, -4, and H, 8, 8. Okay, easy. So let's label x1, y1, just like we would with slope. Same with x2, y2. So x1, y1, x2, y2. And then we are going to go ahead and we are going to use our formula. So again, it's x2 minus x1 squared plus y2 minus y1 squared equals distance squared. So subtract our x's first. So we have x2, which is 8, minus x1, which is 3 squared, plus y2, which is 8, minus -4 squared equals to our distance squared. Be careful with your double negatives, of course. Whenever you have a negative sign, a negative number, right, as one of your values, make sure you have that double negative situation happening here. Okay, let's keep going. 8 minus 3 is 5, so that's 5 squared. Plus 8 minus -4 is the same as 8 plus 4, so that's 12 squared equals to distance squared. 5 times 5 is 25, plus 12 times 12 is 144. Okay, keep simplifying. 25 plus 144 is 169. And once you get one number equals to d squared, you're just going to take the square root of both sides like we did earlier. And the square root of 169, you can type it in your calculator, double check, but it's 13, because 13 times 13 is 169. So the distance here between the points is 13 units. And we're done with that one. Okay, example 5. Find the distance between the points C, -7, 4, and D, 5, 8. Leave answer in the simplest radical form. Okay, perfect. So label our x1, y1, x1, y1, x2, y2. And we are going to go ahead and plug that into our distance formula. So we are going to have our x's first. So 5, which is our second x, minus -7, which is our first x, all of that squared, plus y2, which is 8, minus y1 is 4, squared, is equal to the distance squared. 5 minus -7 is the same as 5 plus 7, so that's 12 squared, plus 8 minus 4, which is 4, so 4 squared, and that's equal to the distance squared. 144 plus 16 is equal to d squared. 144 plus 16 is going to be 160. And now we square root both sides. Okay. Now to square root 160, if you do it in the calculator, it will give you a decimal, 12.649, etc. So we don't want to write that answer. We don't want the simplest radical form answer. Okay. And so instead we're going to simplify this radical. We're going to break it down. So 160 is 10 times 16. 10 is 2 and 5, which are now both prime. 16 is 4 times 4, not prime. Break those down to 2 and 2 and 2 and 2. Now we can write this answer in a radical. So we have just be careful here, 1, 2, 3, 4, 5 2s and a 5. Okay. So 1, 2, 3, 4, 5 2s and a 5. And so pair of 2s, and then 2 singles. So if they have a pair, they have a square root. So I can take 2 times 2 in front of my radical, and then 2 times 5 is 10 inside. So that's going to be 4. Actually, let me leave it separate like that. Okay. And then 2 times 2 is 4, and then square root of 10. Okay, and that's going to be the distance between those 2 points. All right, last but not least, so for number 6, prove that triangle ABC is isosceles by showing that 2 of the triangle's lengths are equal. So the definition of isosceles is exactly what it just stated. So to be isosceles, it would have to have exactly 2 of the triangle sides being equal. Not 3, right? 2, exactly 2. So which 2 look like they're probably equal? We're going to determine that they are equal and then make sure that the third one is not, because of course the third one would have to be different for it to be isosceles. Okay, so taking a look here, it looks like just by looking at it that BC is probably a little longer than the other 2. So I'm thinking that AB and AC are the 2 that are equal. I'm thinking that these 2 are the 2 that are equal. So what we want to show is that AB equals AC. Okay, we want to show that AB equals AC. So we're going to find AB, and we're going to find AC, and we're going to show that they're equal. Okay, so to find AB, we can write down the coordinates and use the distance formula. Or we can just draw a triangle. I'm just going to go ahead and draw a triangle for the sake of this one, since we have the picture. And this triangle is a right triangle. The height is 1, 2, 3, 4, 5, 6, 7, 8 units. And the width is 1, 2, 3, 4, 5, 6 units. Okay, so for AB, and we can call, we can just leave that as AB, this length here, this hypotenuse, AB, like we did earlier. So we can go ahead and say that the 2 legs are 8 squared plus 6 squared, and that's equal to AB squared, right? So then 8 times 8 is 64, plus 6 times 6, which is 36. And then that's 100 equals AB squared. Of course, when we square root both sides, the square root of 100 is 10. So AB is 10. Okay. Now taking a look at AC, separate those. AC, if we draw a triangle, mess mine up a little bit, that's fine. The width of AC is 1, 2, 3, 4, 5, 6, is 8. And the height is 1, 2, 3, 4, 5, 6. Okay, so we have 8 squared plus 6 squared equals AC squared. Right, we're calling this length here AC. Those are the same numbers as before, right? We're obviously going to get the same answer. 64 plus 36 equals AC squared. This is the exact same numbers that we had. Okay, so we're going to get 100 equals AC squared. And just like before, when we square root both sides, we get that AC is 10. Okay, so far we can see that those 2 values are the same. What I want to make sure of is that that third length that we said was a little bit longer is in fact not the same length as 10, so that it is for sure an isosceles triangle. Okay, so if I draw myself sort of a long skinny triangle here from B over until it meets with C, then I end up with a width of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then a height of just 2. So when I go to find BC, I have 14 squared plus 2 squared equals BC squared. Well, 14 squared is already much more than 100. That's 196. Plus the 4 for 2 squared is equal to BC squared. Well, that means that 200 is equal to BC squared. And when I square root, right, both sides, if I just put it in my calculator, I can see that BC is the square root of 200, which is about equal to 14.1. Okay, if I put that in my calculator, which of course is not the same as we got for AB and AC, because we got 10 for AB and AC. Okay, so that's not equal to 10. So since AC and AB are the same, but BC is different, then of course that shows that triangle ABC is isosceles. Okay, so triangle ABC is isosceles since AB equals AC. And BC is not equal. Okay. All right, that's it for these notes. Thanks for watching.